Okay, let's jump right in today. There's this uh, common idea about catastrophes, right? Like a giant asteroid hitting Earth.
Yeah, the idea that it's basically a cosmic reset button for life, wipes the slate clean.
Exactly. But what if that whole picture, how life bounces back, is actually, well, a bit off?
Hmm.
Welcome, everyone, to the Deep Dive. This is where we unpack complex stuff and try to find those clear, maybe even surprising insights.
And today, yeah, we're diving into some really fascinating new research. It fundamentally challenges that reset idea for mass extinctions.
Right. And it connects directly to the biodiversity crisis we're facing now. So our mission today is to get into this new way of thinking, focusing less on just counting species and more on the roles they play, their jobs, so to speak.
And the source for this is some great new work looking at probably the most famous extinction event ever.
The one that got the dinosaurs.
Precisely.
Yeah.
66 million years ago.
So let's start with the old view. What was the sort of standard scientific take on mass extinctions for a long time?
Well, for ages, it really was seen as that reset button. The thinking went, huge event happens, dominant life forms get wiped out.
Leaving lots of empty space.
Exactly. Empty niches, ecologists call them. And then brand new species evolved to fill those gaps. It was seen as this major driver, fundamentally changing evolution's path each time.
And just to clarify, when we say mass extinction, what's the threshold? How bad does it have to be?
It's pretty stark, actually. The scientific definition is when at least 75%, three-quarters of all species disappear globally.
Wow.
And it has to happen in a geologically short time frame, which sounds long to us, but is maybe 2 million years or less.
Okay.
And we know of 5 truly massive ones like this in the last half-billion years, the Big Five. Each one historically was thought to have just radically reshaped life.
Okay, so that's the traditional picture, but now there's this new study shaking things up.
That's right. Really groundbreaking work focusing on that specific event, 66 million years ago, the end of the Cretaceous period. It's called the KPG extinction.
KPG, got it, the dinosaur killer.
Yeah. But here's the twist. Instead of looking at T-Rex and Triceratops,
Which everyone loves.
of course, but this study looked somewhere else entirely, down on the seafloor, at things like clams, mussels, snails, benthic marine invertebrates.
Okay, interesting. Why them? Why focus on seafloor creatures instead of, say, the big land animals?
Several really good reasons. First, there are just tons of them in the fossil record. They fossilize really well.
So lots of data.
Exactly. Loads of data. And second, they show incredible diversity in what they do, their ecological roles or functions. That variety is key for this kind of study.
Right, you mentioned ecological roles. How do the researchers actually define and classify those? What does a role mean here?
They got really specific. They managed to classify all these marine species into 37 distinct ecological roles.
37 different jobs.
Sort of, yeah. Think of it like a functional profile. So, for example, one role might be a stationary filter feeder living buried in the sand. Another might be a mobile grazer, like a snail crawling over rocks eating algae. Some animals even combined strategies. They looked at what it ate, how it moved, and where it lived its whole lifestyle, essentially.
That sounds like a really detailed way to look at it, beyond just naming species.
It is. It shifts the focus from who was there to what was being done in the ecosystem.
So they have these 37 roles defined before the asteroid hits. What happened when the extinction event actually struck? Did most of those roles disappear along with the species?
This is where it gets really surprising. We know the KPG event was devastating. About 60% of marine species went extinct, a huge loss.
60%, okay.
But, and this is the kicker, despite losing well over half the species, the study found that only 2 of those 37 ecological roles vanished completely.
Wait, only 2 roles out of 37 when 60% of the species died.
Exactly. It's incredibly counterintuitive. It suggests the ecosystem's functional structure was much, much more resilient than we thought.
That really challenges the wipe the slate clean idea. If most of the jobs were still there, were the roles that survived common ones? Or did even rare roles hang on?
That's another fascinating part. Even roles that weren't very common, didn't have many species doing them, mostly survived the extinction.
So it wasn't just the dominant functions that made it through?
No. And they ran simulations, statistical tests. If the extinction had just been random, hitting species by chance.
You expect way more roles to disappear.
Way more. The probability of losing only 2 roles just by luck, less than 1%. It strongly implies the extinction was selective, but not primarily targeting the ecological roles themselves. The functions were somehow protected, even as the individual species carrying them out suffered huge losses.
Okay, so the roles are surprisingly tough. But what happened after the dust settled? In the millions of years since? Did evolution then create a whole bunch of new roles? Did the system fundamentally change later on?
Well, yes and no. Over the next 66 million years, some new ecological roles did evolve. The researchers identified about 12 new ones appearing.
12 new ones. Okay, so some innovation happened.
Definitely. But, and this is really crucial, these newly evolved roles mostly stayed quite rare. None of them became major players, functionally speaking.
Ah, so they didn't take over the ecosystem.
Not at all. The dominant ecological roles we see in marine ecosystems today are overwhelmingly the same ones that already existed before the dinosaurs went extinct.
So the extinction shuffled the deck in terms of which species were doing the job.
Exactly. A massive reshuffling of the players.
But it didn't really change the game itself, the fundamental structure of how the ecosystem worked.
That's the core finding. The authors put it perfectly. The extinction restructured but did not reconfigure these marine ecosystems. Population numbers crashed, species vanished, but the overall functional diversity, the variety of things being done, largely persisted.
Was anything important lost permanently, though? Even if most roles survived, did any unique functions disappear forever?
Yes, and that's important not to gloss over. While the overall system was resilient, those two roles that did vanish were gone for good. One specific example they mentioned is really interesting. A type of clam
Okay.
that lived in symbiosis with algae, kind of like modern corals, and actually built reef-like structures. That specific way of life, that role, disappeared 66 million years ago and has never reappeared.
Wow. So even with overall resilience, unique functions can be lost forever.
Absolutely. Some things, once gone, might be gone for geological timescales, maybe permanently.
This whole perspective, looking back 66 million years, feels incredibly relevant now. Scientists keep warning we might be in the early stages of a sixth mass extinction, driven by us this time.
That's the sobering context, yes. Whether it's climate change, habitat destruction, pollution, the pressures are immense.
So based on this KPG study, what's the big lesson for us today facing our own biodiversity crisis?
I think the most crucial takeaway is that we need to shift our focus. It's not just about counting the number of species we're losing, as important as that is.
It's about the functions, the roles.
Precisely. We need to pay much more attention to the variety of ecological roles that species play. Are we losing unique ways of life within ecosystems?
Because those might be the things that, like that reef-building clam, never come back.
Exactly. If you lose a unique ecological function, the ecosystem might never fully recover that capability, no matter how many new species eventually evolve millions of years down the line. They might not do the same job.
So this reframes conservation, doesn't it?
Yeah.
It's not just about saving species A or species B, but about preserving the functional integrity of the whole system.
It really does. It pushes us towards prioritizing the preservation of a wide array of ecological roles. We need to think about maintaining functional diversity.
Can you give an example of what that looks like in practice?
Well, think about efforts beyond just protecting one endangered animal. Consider projects aimed at restoring entire ecosystems. For instance, there are community organizations like Planet Wild is one example people might know. They do practical work like restoring the forests in Mexico where monarch butterflies overwinter. That's not just about saving the butterfly, beautiful as it is.
It's about their role.
Yes, it's about protecting their crucial role as pollinators, their place in the food web, the health of that entire forest ecosystem, which depends on many interacting roles. It's about preserving the function, not just the species count in isolation.
Okay, so let's quickly recap the main insight from our deep dive today. This idea of mass extinctions being a total reset, it seems that's not quite right.
No. This research strongly suggests that while species suffer immensely, the underlying functional structure of ecosystems, the variety of ecological roles, can be surprisingly resilient.
It's more of a reshuffling of who does what, rather than tearing up the whole playbook. The players change, but the game mostly stays the same.
That's a good way to put it. Most roles persist, even through absolute catastrophe.
Which really changes how we define survival during an extinction, doesn't it?
It does. And it leaves us with a really important question, especially for you listening. When we talk about protecting biodiversity today, are we focused on the right things?
Are we thinking enough about preserving not just species numbers, but the unique jobs, the essential functions that keep our planet's ecosystems working for the long haul?
Something to think about, definitely. How might this shift in perspective change how we approach conservation going forward?